Here you go. Example 16. How does the momentum of the expelled CO2 compare to the change in momentum of the tricycle and its rider? All right. Well, let's take a look at this picture real quick. Okay. So here's the picture. Which way is the momentum of the expelled CO2? To the right or to the left?
Right.
To the right. Which way is the momentum of the rider? To the left. So how does the momentum of the CO2 coming out of the back of the fire extinguisher compare to the momentum of the tricycle rider? Opposite direction and equal magnitude, right?
What do you mean
So
by equal magnitude?
they're the same number. So if the momentum of the CO2 coming back is negative 10, Sergio, then the momentum of the rider going forward is positive 10. So opposite direction, but equal in magnitude. Does that make sense?
Yeah.
Does that make any questions about that?
Nope.
So if I wanted to find the velocity of the CO2 going backwards, right? I need to find the momentum of what?
Him going forward?
Of him going forward. Perfect. I need to find the momentum of the tricycle and rider going forward, and then I can find the velocity of the CO2 going backwards since I know its mass. Right? Or I can calculate its mass. So, example 17 says, if the 75 kilogram rider sprays 300 grams of CO2, which results in a 10 kilogram tricycle reaching a speed of 3.2 meters per second, how fast is the CO2 traveling when it leaves the fire extinguisher? Okay. Richard, get lights for me, please. Thank you. Oh, Socotola left over. All right, so what's the mass of the tricycle?
300.
Nope.
10.
Tricycle.
10 kilograms.
10 and 75 because it's the tricycle plus its rider. So 85 kilograms. Right? What's the mass of the CO2?
75.
75. Nope.
No, 300 grams?
300 grams. Okay. Divide that by 1,000
How do you know what to divide it by?
because kilo means 1 times 10 to the third. So if I want to go from grams to kilo, I need that my grams need to be 1 times 10 to the third. Okay. Goes all the way back to unit 1. 0.3 kilograms. Right? The velocity of the tricycle at the end is 3.2 meters per second, right? What's the velocity of both initially? 0. Okay. So here we have our list of things. Okay, here's our list of things. So we know momentum and velocity. Oh, not plus. Initial equals mass and velocity of tricycle final and mass and velocity of CO2. Goodness. You can tell it's Monday, huh? Mass and velocity of CO2 after. Does that make sense, guys?
Yes.
Yeah? So initially, is the tricycle moving? No. So 0 equals, help me out?
0.
No.
80.
It will equal 0. But not yet. What?
85.
85 times
3.2.
3.2. Good. Plus
0.3.
0.3
VC.
VC. And now we can solve, can't we? What's 85 times 3.2? We should have all done this, shouldn't we have?
272.
So 0 equals
272.
272. Thank you, Lynn. 272 plus 0.3 VC. So now what do I do? Oh, you don't do that yet. Good. Subtract 272 from both sides. Yeah, I know. And when it's simple problems, Kevin, it works out if you skip steps. But when it's more difficult problems, skipping steps can be hazardous to your.
I already put it over there.
Okay, it can be hazardous to your grade, right? So what do I do now? 11.3. Julian, does this make sense? Okay, so 272 divided by 0.3, what is that? Negative 906. We'll go with negative 906 meters per second. We can call it 907, right?
Is that the?
Yeah.
So that means the CO2 leaves the fire extinguisher at 907 meters per second. That's pretty fast, right? Why is it so much faster than the tricycle?
Because its mass is a lot less.
Good, its mass is a lot less. Should I keep it negative or should I just make it positive? What does the negative tell us, Kevin?
That's the other way.
Good, so in the opposite direction. So since this is negative, the tricycle velocity is positive, that tells us that the tricycle is going one way, the CO2 is going the other way. Good. Any questions?